to ReMathable. Today we are going to delve into a topic that has already been covered, but in a very concise way. So upon request from some of you, I'm going to make a detailed video regarding the circle theorems and their application to textbook questions. However, I'm not going to discuss these key terms. If you have any confusion or problem regarding these key term vocabulary of the circles, please watch the video that has already been uploaded in the pre-IGCSE O-level stream. Now, without further delay, let's dive in. So as already discussed, we've divided the circle theorems into three properties: the tangent properties, chord properties, and angle properties. Let's begin with the tangent properties. The first tangent property is that the tangent at any point on a circle is at right angles to the radius at that point. Now, before I discuss this theorem, I hope all of us are clear on what a tangent is. A tangent is a line that touches the circle at one point. So it does not intersect the circle or cross the circle. It touches the circle at one point only. Okay? So we can have a tangent to the circle at any point. However, the condition for a line to pass out as a tangent is that it should touch the circle at one point only. So the tangent and the radius. What is the radius? A line that stems out or originates from the center of the circle to the circumference. Okay, so the tangent and the radius, they make a 90-degree angle. In very simple terms, any radius, any tangent will make a 90-degree angle at the point of contact. So for example, if this is the tangent, this is the radius, and this is the tangent, so this will make a 90-degree angle. Okay. The next tangent property involves a tangent guide. Now, what is a tangent guide? So two tangents from an external point. What is an external point? A point which is outside the circle. So in this case, it is point C. So two tangents from an external point, which is C. So this is the first tangent, this is the second tangent drawn. Okay, so two tangents from an external point to the circle are equal in length. Okay, so this theorem tells us that AC is equal to BC. Okay, and from the previous tangent property, the radius and tangent make a 90-degree angle. So we know that the radius and the tangent will make a 90-degree angle. Radius, tangent will make a 90-degree angle. Okay, and we also know that the radii are going to be equal. And if you notice, this is a guide, and hence the name, the tangent guide. Another angle property that we can derive from this is that the opposite interior angles of the tangent guide are supplementary, which basically means that they sum up to 180. So since this A plus B is going to be 90, we know 180. 90 plus 90 is 180. So this angle, let's call it A, and the opposite interior angle, let's call it B. They should add up to 180 as well. So this is the second property that we can derive from a tangent guide. So the first one is that AC is equal to BC, and the second one is that angle A plus angle B is equal to 180 degrees. Now, an extension of the tangent guide is this, that the line joining the external point, again, what is the external point? A point which is outside the circle, and in this case, it is this point, point C. So the line joining the external point to the center of the circle. So this is the center of the circle, this is the external point. So the line joining the external point to the center of the circle bisects the angles between the tangents. Okay, so bisect means to divide equally into. Okay, so this angle was angle A, right? This entire angle was angle A. Bisecting the angle means that this line would divide the angle into equal parts. So this is going to become A divided by 2, A divided by 2. Similarly, this will become B divided by 2 and B divided by 2. So the property states, so this was the angle, right? This is angle A, this is angle B. The line connecting the center and this external point will bisect the angle, which means this would become A divided by 2, A divided by 2, and this angle would become B divided by 2, B divided by 2. So let's write this down. This is A over 2, B over 2, B divided by 2. Okay. Let's put these properties to application. Okay. So TA and TB are tangents to the circle with center O. Given that ATB is 50 degrees, find ABT and OBA. So before finding any angle, let's mark all the right angles, all the properties that we've learned so far. So as you can see, this is a tangent kite. Why? Because we have an external point T and we have two tangents drawn from this external point to the circle. So we know that BT and AT are going to be equal because this is our tangent kite property, right? So let's mark them as equal. And we know that angle between a tangent and a radius is 90 degrees. So let's mark this as a right angle. Okay? All right. Now they're asking us to find ABT, which is ABT. So it is this angle. Okay, let's mark it. So they want us to find ABT, this angle. So what are we going to do? So we have the triangle ABT, right? And we know from tangent kite property that AT is equals to BT. Okay. So if you notice that this becomes an isosceles triangle, right? So these two sides are equal. Hence, these two angles will also be equal. Okay. So this angle will be equal. So let's assume that this angle is x and therefore this angle will also be x. So now we know that the sum of the interior angles of a triangle is 180. So x plus 50 should be 180 degrees, right? So 2x is equals to 180 degrees minus 50 degrees. 2x is equals to 130 degrees, and therefore x is equals to 130 degree divided by 2. X is equals to 65 degrees. Okay, so we know that this is angle 65. Okay, so angle ABT is equals to 65 degrees. Next, they're asking to find angle OBA. OBA, this angle. Okay, let's color this angle. This. Okay, so they want us to find this peach pink type angle. Okay. Now we know that the angle between a radius and a tangent is 90 degree, right? So both of these angles should sum up to 90. And we know that this is 65. So out of 90, this is 65. So what is this angle going to be? So this is 90 degrees. I don't know why sides. Wait. Okay, so this is 90 degrees and we need to find this angle. Okay, so OBA, angle OBA is going to be 90 minus 65, which gives you 25 degrees. Another way to formulate your equation is that let's assume this is y. So 65 plus y should be equal to 90 degrees. So y is going to be 90 minus 65 degrees, which gives you y as 25 degrees. Okay, I hope this question was clear. Okay, so this is the exercise, and now I'm just going to apply the theorems and properties here to find the angles marked with a letter and explain your reasoning. So you have to give a one-line reason for your calculations. In the past paper question video that I'm going to inshallah make very soon, I'm going to list all the possible reasons from the syllabus, because the examiner has explicitly stated that the candidates are expected to give reasonings from the syllabus. Okay, so let's first discuss these questions. So in the first question, we have a tangent and a radius. So we have a 90-degree angle here. Now, this is a suggestion that whenever you have you're solving a circle question, mark all the radii and all the 90-degree angles first. Okay, so how do you identify a radius? So you look at the center, and any line originating from the center to the circumference will qualify as a radius. Okay, so let's mark this as the radius. And then we know that the angle between a radius and a tangent is 90 degrees. So I have marked that as 90 degrees as well. Now, to find the value of A, we need to formulate an equation. So look at triangle OBC. We have all three angles with one unknown. So we know that the sum of the interior angles of a triangle is 180. So 4A plus A plus 90 should add up to 180. So we have 5A is equals to 180 minus 90. A is equals to 90 divided by 5. So we know that A is equals to 18 degrees. Okay. Now let's look at question number 2. Okay. So this is the tangent. This is the radius. So this is going to be 90 degrees. Let's mark it as 90 degrees so that we know that this is 90. Okay. So to find angle X, let's focus on triangle BCO. Okay. So we know angle B is 90. This is 50. So X is going to be, so 90 plus 50 plus X should be 180. X is equals to 180 minus 140. X is 40 degrees. Okay. So we have X as 40 degrees. Now, but what about Y and Z? So we did not mark the radii here. So this is the center. Lines originating from the center to the circumference qualify as the radius. So these two lines are equal. If these two lines are equal and we focus on triangle BDO, we know that this is an isosceles triangle. So this angle and this angle would be equal. So if this is angle Y, okay, So if this is angle y, this would also be y. So let's label it as angle y. So we know that y plus 50 should be equal to 180. 2y is equals to 180 minus 50. Y is equals to 130 divided by 2. So y is equals to 65 degrees. Okay, so what is the value of y? It is this is 65. Okay, and to find z, we know that the angle between the radius and the tangent is 90. So 65 plus z should be 90 degrees. Okay, so 65 plus z should be 90 degrees. So z is equals to 90 degrees minus 65, which gives you 25 degrees. So angle z is 25 degrees. Okay. Let's look at question number 3. So again, a tangent, radius. This is also a radius. So let's mark all the radii. And the angle between the tangent and the radius is 90 degrees. Okay. So we know that 5e plus e should be 90 degrees, right? Both these angles should sum up to 90 degrees. So 6e is equals to 90 degrees. E is equals to 90 divided by 6, which gives you 15 degrees. E as 15 degrees. Okay, and if E is 15, 5E is going to be 5 into 15, which is 75 degrees. So this is 75 degrees, and since OBD is an isosceles triangle, this is also going to be 75 degrees. So because we know that the sum of interior angles of a triangle is 180, so 75 plus C should be equal to 180 degrees. So C is equals to 180 degrees minus 150 degrees. So C is going to be 30 degrees. Let's have a look at question number 4. So external point B, two tangents drawn to the circle. So AB and BC, they're going to be equal. Let's mark them as equal angles. So this becomes an isosceles triangle, and therefore this angle is also going to be F. And we know that angle between a radius and a tangent is 90 degrees. So this is going to be 90 degrees. Now to find angle F, we are going to use the sum of interior angles of a triangle. So F plus 80 should be equal to 180 degrees. 2F is equals to 180 degrees minus 80 degrees. F is equals to 100 divided by 2. So angle F is going to be 50 degrees. Okay. So if this is 50, and we know that G plus 50 is basically 90 degrees, so we can also find angle G. So G plus 50 degrees should be 90 degrees. So we know that angle G is going to be equal to 40 degrees. Question number 5. Again, we have an external point C, two tangents drawn to the same circle from this point, which means DC and BC are going to be equal, which makes BDC an isosceles triangle. So if angle B is 70, this is also going to be 70 degrees. So to find angle I, we are going to use the sum of interior angles of a triangle. So 70 plus I is going to be 180. So I is going to be 180 minus 140. I is going to be 40 degrees. And again, no, we do not have a center. So they've not marked center O. So now we're going to figure out the value of angle H through another process. Let's see what. So a triangle ADB is an isosceles triangle. So if this is 70, this is going to be 70 as well. So how do you decide which two angles are equal? So if this is an isosceles triangle, you might be tempted towards saying this is angle H. So the way to clarify this is that the angle opposite a line is basically a pair. So this line is pairs with this angle. The line which is opposite, the angle which is opposite to the line. All right. Similarly, this line, so D and B points construct line DB. So the angle opposite to, or basically the third vertex of the triangle. So angle point D and B are making the line segment DB, which is the third vertex of the triangle, angle A, point A. So the angle opposite to line DB is going to be the pair for that line. Okay, so since this line is equal to this line, so this angle is the pair for line DB. This angle is going to be the pair for line AD. Hence, this is 70 degrees as well. So again, we are going to use the sum of interior angles of a triangle. So 70 plus 8 should be 180. So 70 plus 8 should be 180. So H is going to be 180 minus 140, which gives you the value of H as 40 degrees. So the questions are now becoming slightly repetitive. Okay, so again, external point, two tangents. So these are going to be equal. Let's mark them as equal, and we again do not have the center marked. So let's look at triangle PQR. So this is an isosceles triangle because of the tangent kite properties. So if this angle is 40 plus 32, which gives us 72, so then this angle is also going to be 72, right? And then we can find the value of n, because the sum of interior angles of a triangle is 180. So 72 plus n should be 180. Okay, so let's do it. So since this is 72, 40 plus 32, this will be 72 as well. And we are looking at triangle PQR, so this triangle, and we need to find the value of this angle. So 72 plus n should be 180 degrees. So n is equals to 180 degrees minus 414. So n is going to be 636 degrees. Okay. So what you should do, or how you should follow the video, is that you should pause here, try and solve for the unknown values yourself, and then unpause and check your answers against mine. Okay. Okay. So we have a tangent here, but no center is marked, so we do not know if this passes through the center or not, since it is not clearly given. However, we know that this is an isosceles triangle. These two sides are equal. So since this is 50, this is the angle side pair. So which is the angle opposite this line? This line, it is angle M. So we know that angle M is going to be 50 degrees. Okay, and now let's have a look at triangle BED. BED. We know that two sides or two angles of triangle BED are 50 and 50. So 50 degrees plus 50 degrees plus P degrees should be equal to 180 degrees. So P is equals to 180 minus 100 degrees, which gives you P as 80 degrees. Okay. And finally, we know that angles on a straight line add up to 180, right? So since this is 80, this is 50. So 80 plus 50 plus K should also sum up to 180. So 80 plus 50 degrees plus K should be equal to 180 degrees. So K is equals to 180 degrees minus 130 degrees. So K is equals to 50 degrees. Okay, and so in this question, the center is marked clearly. All the lines originating from the center to the circumference of the circle qualify as the radius. So OA is a radius and OC is also a radius. Okay, and then we have a tangent DC. So angle between tangent and radius is 90 degrees. So this total is going to be 90 degrees, right? And we also know that OAC is an isosceles triangle. This side has a pair with angle P, and since this side is equal to OC, the angle, its pair angle will also measure up to P degrees. So basically, this is P as well. Okay, and we can use theorems that since we haven't covered all the theorems, I'm not using a theorem such as angle at center is twice the angle at the circumference. So I'm not using them because we have not covered them so far. But if you know some of the theorems that can be applied here, please feel free to do that. Okay, so what I'm going to do is I'm going to try and solve this question using only the tangent properties that we've covered so far. Okay, so we know that these two angles should add up to 90. So 44 plus P should be 90 degrees. So let's do that. 44 degrees plus P should be equal to 90 degrees. So P is going to be 90 degrees minus 44 degrees, which gives you 46 degrees. So P is equals to 46 degrees. Okay. Now we need to find the value of N. So we are going to look at triangle ABC, okay, ABC. So we have this angle as 28 plus 46, the second angle as 44 degrees, and this is 46 plus N. So we need to find the value of N. Let's formulate the equation for the sum of interior angles, sum up to 180. So 46 plus 28, this angle, plus 44, this angle, plus 46 plus N, this angle should be 180 degrees. So N is going to be 46 plus 28 plus 44 plus 46 is 164. So 180 degrees minus 164 degrees, which gives you the value of angle N as 16 degrees. Okay, so we have covered the entire exercise involving the application of tangent properties to circles. I hope it is clear. And let's move on to the next property. The next tangent property is the alternate segment theorem. So let's read what the property states. The angle between a tangent and a chord at the point of contact is equal to the angle subtended by the chord in the alternate segment. Now, before we try and understand this property, let's make sure that we understand the key vocabulary terms used in this theorem. What is a tangent? A tangent is a line that touches the circle at one point. So line DE is touching the circle at point C only. What is a chord? A chord is a line which is connected by 2 points on the circumference of the circle. Okay, so any 2 points, for example, A and B, they are connected through the chord AB. Points AC connected by the chord AC. Okay, and what is a segment? So basically, a chord divides the circle in 2 segments. So this is one segment, also known as the minor segment. And which is the other segment? This is the other segment, also known as the alternate segment. Okay, so look at chord AC. So we have this small segment. And what is the alternate segment? This entire region. Okay, let's look at chord BC. So this is one segment. And which is the alternate segment? The other segment. Okay, so I hope all the terms are clear now. Now let's reread the theorem. So the angle between a tangent and a chord at the point of contact. So any chord and tangent. And what is the point of contact? This is the point of contact. So the angle between the chord and the tangent at the point of contact would be this one, is equal to the angle subtended by the chord in the alternate segment. Okay, so the angle between this chord and the tangent is this green angle, right? Now this angle is equal to the angle subtended by the chord. So which is the chord that we're looking at? We're looking at chord BC, right? And which is the segment where the angle is made? So it is this segment, right? So which is the alternate segment going to be? This one. So now look at the ends of this chord. The ends of the chord are C and B. And now see where in the alternate segment is this chord subtended an angle at the circumference of the circle. Okay, so let's see. So see from here and here. So this chord is making an angle in the alternate segment at the circumference. So this is that angle. So this angle is going to be equal to this angle. So this is the theorem. Okay. Now let's see if the other chords also qualify. And apply the alternate segment theorem. So let's look at chord AC. Okay, so we are now looking at the chord AC. So this is the chord. What are the ends of this chord? So A and C. Okay, so angle made between a tangent and a chord, since we're looking at chord AC at the point of contact. So it would be this angle, right? So this angle would be equal to the angle subtended by the chord. So which is the chord that we're looking at? Chord AC. This is the segment where the angle is made. So where is the alternate segment? This is the alternate segment, right? So angle subtended by the chord in the alternate segment. So these are the ends of the chord, and see from here they are making an angle at the circumference at point B. So angle B is equal to this angle. Okay. Now let's try and apply this alternate segment theorem. This theorem has recently been added to the syllabus, so rest assured that it will be tested in the coming years quite frequently. So make sure you understand it, and you've applied it to as many questions as possible. There might not be a lot of past paper practice questions with respect to this theorem because it is a recent inclusion, but we do have textbook questions where we can learn its application. Okay, so I would suggest that you pause the video here, try and find the angles marked with the letter, and then later unpause it and check your answers against mine. Okay, let's look at question number 1. So this is a tangent, and we have a chord AC. Chord AC is equals to chord CB. And if we think about the application of the alternate segment theorem, we know that the angle between the tangent and the chord at the point of contact, so it would be this angle, is equal to the angle subtended by the same chord, so chord AC in the alternate segment at the circumference. So it would be this angle. So basically this angle would also be equal to A. Okay? I hope this is clear. If not, please rewatch this part. Okay, so the angle made by the tangent and the chord at the point of contact, so basically this angle is equal to the angle subtended by the same chord. Which chord is that? AC chord in the alternate segment. So this is the segment that we were discussing initially. So which is the alternate segment? This is the alternate segment. So the angle made by chord AC in the alternate segment at the circumference, they are going to be equal. Hence, this angle is equal to angle A. Okay. Now, we also know that angles on a straight line add up to 180. Since this is a straight line and this is 110, this would be 70 degrees, right? And because this is an isosceles triangle, if this is 70, this angle is also going to be 70 degrees. And using the alternate segment theorem, we can safely assume that A is also equal to 70 degrees. Let's have a look at question number 2. So let's see. This is a tangent. This is the chord. So the angle made at the point of contact between the chord and the tangent. So basically this angle is equal to the angle subtended by the same chord. Which chord is that? That is chord AC in the alternate segment. So this is the segment that we have currently. And which is the alternate segment? The rest of this is alternate segment, right? So the angle subtended by the chord, so these are the two ends in the alternate segment. So basically this is going to be B. So this angle is also going to be B using alternate segment theorem. Okay, so this is B. Okay, and again we know that angles on a straight line add up to 180. So if this is 48, this would be 180 minus 48. So 180 minus 48 would give you 132 degrees. So this is 132. And now let's have a look at triangle ABC, right? So this is 132, this is 25. We can find angle B here. So 132 plus 25 plus B should be equal to 180 degrees. B is equals to 180 minus 157 degrees. So we have B as 23 degrees. And if this is 23 degrees, this is also going to be 23 degrees because of the alternate segment theorem. Okay. So we have a tangent and we have a chord. So the angle made between a tangent and a chord at the point of contact is equal to the angle made by the same chord, which is chord AB, in the alternate segment. So look at the ends A and B and see if an angle is made from the ends of the same chord at the circumference is equal So this angle is C, so this angle will also be C according to the alternate segment theorem. Okay. Now, get the other tangent CB, and the chord AB again. So the angle made between the tangent and the chord at the point of contact, so this angle should be equal to the angle made by the ends of this same chord. So we're talking about AB in the alternate segments. So stemming from B, stemming from A. So basically this is also going to be equal to angle C because of the alternate segment theorem. So now let's have a look at triangle ABC. We know that the sum of the interior angles sum up to 180 of a triangle. So 82 plus C should be equal to 180 degrees. So 2C is equals to 180 degrees minus 82 degrees. So C is going to be 98 divided by 2. So C is going to be 49 degrees. Okay. Last question. So we know that this is 47, this is 38. This is the tangent. So angle made between the tangent and a chord. So here we are talking about chord AB. At the point of contact, they make an angle of 38 degrees. So that is going to be equal to the angle made by the ends of the same chord. So ends AB in the alternate segment. So we do not have such an angle. Okay. But we know which angle would that be. So AB here and here. Okay, so this will be 38 degrees. I don't know if this will be of any use to us or not, but let's see. Okay, now they're saying, let's look at the other chord. So tangent, chord, at the point of contact, it's 47 degrees. So angle made by the ends of the same chord, this and maybe this. Okay, so this will be 47. Okay, all right. So I've figured out how we are going to do this. Okay, see. So angle made between the tangent and the chord at the point of contact is 38 degrees. It will be equal to the angle made by the ends of the same chord in the alternate segment. So let's look at A and B. So see, this and this, right? So this should be 38 degrees. Let's draw it out. Okay. So from this point and this point, we can draw this angle. So this angle should be equal to 38 degrees using the alternate segment theorem. Let's look at the other tangent, other chord. So this is the tangent, this is the chord. What is the angle that they're making at the point of contact? 47 degrees. Now let's see what is the angle subtended by the ends of the same chord. So see D, and from A, that is what we have. So this is going to be 47 degrees using the alternate segment theorem. Okay. So this is going to be 47 degrees. And we know that angle D is going to be 38 plus 47 degrees, because this is angle D. So this is 47, this is 38. We're going to add them together to evaluate angle D. So D is going to be 85 degrees. Okay. So I hope the alternate segment theorem is clear. But you need to understand that there might be several ways to work out an unknown angle. So for that reason you have to very carefully explain your reasoning carefully. Okay, you have to give your reasons carefully, how you're going about finding the unknown angle. So there are so many ways that were coming in my mind to solve this question. But since we've not covered the angle properties or the cyclic quadrilateral properties as yet, I was trying to figure out how we could solve this question using the alternate segment theorem. And but there's so many ways to solve this question. On to chord properties. Okay, so the perpendicular bisector of a chord passes through the center of the circle. So before we get into the details of this theorem or property, let's understand what a perpendicular bisector is. So even before that, let's understand what a perpendicular line is. So two lines that intersect at 90 degrees are called perpendicular. Okay, so what is a perpendicular line? A line which intersects the other line at 90 degrees. Intersects or meets the other line at 90 degrees. Okay, now what is a bisector? As already discussed in tangent kite, a bisector basically where the angle or line is divided into two equal parts. Okay, so now what is the difference between a perpendicular line and a perpendicular bisector? So see, this is a perpendicular line. However, it is not dividing the line in two equal parts, right? They're unequal. For a perpendicular bisector, not only does it touches the line at 90 degrees, it cuts the line, or if it's an angle, in two equal parts. Okay, so that is what a perpendicular bisector is. So the perpendicular bisector of a chord, so any line that crosses the chord at 90 degrees and passes through the center of the circle, then we can safely assume that it is the perpendicular bisector of the chord. So any line which cuts the chord at 90 degrees and passes through the center is the perpendicular bisector, which means that the chord will be divided into two equal parts. The converse of this is also true. A line that passes through the center, so a line which passes through the center and is perpendicular to the chord, right? So a line is passing through the center but is also perpendicular to a chord, then it bisects the chord, okay? Or another way to say the same thing is that a line joining the center of the circle to the midpoint of a chord. So a line which joins the center of the circle and the midpoint of a chord. Basically, what is the midpoint of a chord? The midpoint divides a chord into two equal parts, right? So all we know is that a line is passing through the center and the midpoint of a chord. Then we can safely assume that it is perpendicular to the chord. Okay? So these are the three versions of the same property. Let's move on to the second chord property, which states that two equal chords are equidistant from the center of the circle. So if they've given you in the question that chord AB and CD are equal, so that is given to you in the question, that these are two equal chords, then you can be sure that their distance from the center is going to be the same. Okay, so if AB is equals to CD, if that is given to you, then we know that EG, where G is the center of the circle, and GF or FG, they are also equal. Okay, so if two chords are equal, the distance of the chords from the center is also going to be equal. Again, the converse is also true. If two chords are equidistant from the center, so they've not told you that A, B, and CD are equal. What they're telling you is that EG and FG are equal. So the distance from the center to two chords is equal. Then you can safely assume that the chords are also equal. So if the question states that EG is equals to FG, right, where G is the center of the circle, then we can assume, safely assume that AB is equals to CD. Okay, so these are two chord properties that you should know. Let's put them to application. Okay, let's look at question number 1. So we need to find the unknown values. So this is the center. They've marked the center. Okay, so let's mark it as O to avoid any confusions. All the lines originating from the center to the circumference of the circle qualify as the radius. So basically X. This is also X, and this long line is also X. Okay. Now, where does the chord property come into play? So this is the center, this is the chord, right? And this line is intersecting the chord at 90 degrees. So it is perpendicular and the line is passing through the center. So we can safely assume that the chord is divided into 2 equal parts. So if this is under root 32, this will also be under root 32. Let's mark this line as under root 32. This line is X, and we need to find the value of X, right? Okay, and since this entire line is X, I'm going to erase this X to avoid any confusions. Okay. Now, is there any way that we can find the length X or the radius of the circle? Okay, see, we have a right angle triangle and we have 2 pieces of information. We have this side and we have an angle. So we are going to apply trig ratios. If you have any confusions regarding trig ratios, please make sure that you watch the videos which have been uploaded with respect to this topic. Okay, so first we are going to label the triangles. The length opposite to the right angle is the hypotenuse. The length opposite to the angle is known as the perpendicular, and then we had the third one qualifies as the base. So now we need to find X, which is the hypotenuse, and we have P. So which trig ratios relate H and P? I hope all of us know that it's sine. So sine theta is equals to P over H. Theta is the angle, so sine of 45 is equals to perpendicular, which is under root 32 divided by H, which is X, okay? So X is going to be under root 32 divided by sine of 45. Use a calculator to find the value. And the answer is, okay, so under root 32 divided by sine of 45 gives you 8. So the value of X is 8. Let's look at the second question. Okay, so this is the center of the circle. Let's mark it as O. So, okay, so what they're telling us is that the distance between the center and this point is equal to the distance between the center and this point. So these two are equal. So what is the theorem that we've discussed? That if 2 chords in a circle are equidistant from the center, then they are equal. So basically this chord will be equal to this chord. And if this is 3, this will also be 3 using the other theorem, okay? Which is what? That if a line passes through the center and is perpendicular to the chord, then it is the perpendicular bisector of the chord, which means that it is going to divide the chord in 2 equal parts. So if this is 3, this will be 3. Same goes for the other chord, perpendicular and passes through the center, so it will bisect the chord into 2 equal parts. And using the second theorem, we know that because they're equidistant from the center, these 2 chords are also equal. So this chord will be equal to this chord, which means X is going to be 3 and this is going to be 3, right? So X is 3 and this length is 3. Okay, so we have the value of X, which is 3. Now, can we find the value of Y? This is the right angle triangle. And we are given 2 lengths and we need to find the third length. So we can apply Pythagoras theorem, where 8 square, the longest side of the right angle triangle, which is opposite to the right angle, So the Pythagoras states that 8 square is equals to a square plus b square, the square of the other two sides. So which is the longest side? It is 5. So 5 square is equals to 3 square plus y square. 3 square and y the other two sides. So y square is equals to 5 square minus 3 square, which is going to be 25 minus 9. So y square is going to be 16. To cancel out the square, we're going to take square root of both the sides. Okay, so y is equals to 4. Generally with a square root, we always add plus minus bit because this is a length, and a length cannot be negative. We are just going to take the positive value of y. Okay, so y is equals to 4 using Pythagoras. Let's look at the last question. Okay, so this is the center. All the lines originating from the center to the circumference of the circle qualify as the radius. So all these red lines, all of them are the radius of the circle. Okay, and the distance from the chord to the center, this is equal. So which means that this chord is equal to this chord. Okay, and we need to find angle y. Let's see, can we find this angle? Yes, so look at this triangle that I am highlighting in red. So if this is 90, this is 50. So this angle will be 180 minus 90 minus 50. So this angle is going to be 40 degrees, right? Why? Because having a look at this triangle, we can use the sum of interior angles of a triangle. So 50 plus 90 plus the unknown angle, let's call it, we can't call it x, let's call it a, is equals to 180. So the value of a is going to be 180 minus 140, which gives you a as 40 degrees. Okay, now using the property of vertically opposite angles, I hope all of you can see the x here. So this angle is going to be equal to this angle, right? So this angle is going to be 40. But we need to find angle y. So we have a part of angle y. We need to figure out what this part is, right? We need to find this part. Now, because this is a chord and a line passing through the center and is perpendicular to the chord, basically is the perpendicular bisector. It means that it is going to divide the chord into equal parts and is also going to bisect the angle into equal parts. So if this is 40, then this is also going to be 40. Okay, so what is angle y? Y is 40 plus 40, which gives it a value of 80 degrees. Okay, now let's have a look at the other right angle triangle, this one, to find the value of x. So this is 90, this is 40. What is the value of angle x? It's going to be 90 plus 40 plus x should be equal to 180 degrees. So x is equals to 180 degrees minus 130 degrees. X is equals to 50 degrees. Okay, next we have to find angle z. So we know that okay, just give me a moment. So angles on a straight line add up to 180 degrees, right? So if this is 40, angle z is going to be 180 minus 40. So z is going to be 180 degrees minus 40 degrees, which gives you the value of z as 140 degrees, right? So this should add up to 180. Since this is 40, this will be 140. So 140 plus 40 gives you 180. Okay, now let's move on to the angle properties of circles. Okay, the angle in a semicircle is a right angle. So what is a semicircle? A semicircle is half a circle, right? So basically the line which passes through the center of, or the diameter of the circle. Another way to state this theorem is that the angle made by the diameter of the circle at the circumference is 90 degrees. So it can be anywhere as long as it originates from the ends of the diameter. So these two ends can make an angle anywhere at the circumference, and it's going to be 90 degrees. So what is the condition? They should stem from the ends of the diameter, and the angle should be made at the circumference of the circle, anywhere. So that would be 90 degrees. Okay, this is the first angle property. So let's put this to application. So AB is a diameter. Find the size of angle B. Now, since we know that AB is the diameter, angles made at the circumference from the ends of this diameter will be 90 degrees. So look at this. So from A and B, ends of A and B, angle C is made. So this is going to be 90 degrees. Okay, so if this is 90, we know that the sum of angles in a triangle is 180. So 90 plus 37 plus B should be equal to 180 degrees. So B is going to be 180 degrees minus 127 degrees. So B is going to be 353 degrees. Okay. The next angle property is that the angles in the same segment are equal. Okay, so angles made from the ends of the same chord. So look at this red chord. All the angles originating from the ends of this chord and angles made at the circumference would be equal. So see, this is x, right? Same ends, angles made at the circumference, this will also be x. So any angles made from the ends of the same chord will be equal. So this is also going to be x. This is also going to be x. Why? Because it is originating from the ends of the same chord and the angle is made at the circumference. So this is also x. Okay. Anywhere as long as they originate from the ends of the same chord and the angle is made at the circumference. So that is going to be equal. Okay, let's do an example to clarify. Given that BDC is 62 degrees and DCA is 44 degrees, find angle BAC. So they want us to find this angle. Now let's see. This is the chord BD. Okay. So this is one end of the chord and this is the second end. So the first angle made from the ends of this chord is basically 62. Now let's look at the other angle made by the same chord at the circumference. So from B, this is the line, and from C, this is the line. So this angle is also going to be equal to 62. Okay, so angle BAC is equals to 62, and the reason that you're going to give is that angles in the same segment are equal, right? So this is the chord BC. It is making an angle of 62, angle made at the circumference, and from the ends of the same chord, another angle is being made at the circumference, which is this. So this is going to be 62. Next, we have to find angle ABD. ABD. Okay, let's erase this. Okay. So we know that this is 62. Now you have to find angle ABD, which is this angle. Okay, let's change the color. Okay, now see, let's have a look at chord AD, right? So angles made from the ends of the same chord at the circumference. So if this is 44, right? What is another angle made from the ends of A and D? So see, A se ye line aa rahi hai and this is D, right? So this angle is going to be equal to 44. So this is the chord AD. This is the angle made by the chord at the circumference. Now let's have a look at the other triangle made from the ends of AD. So this is A, this is D. So this angle is going to be equal to 44 as well. And the reason that you're going to give is that the angles in the same segment are equal. Okay, so the angle subtended by an arc at the center. So the angle subtended by an arc, let's look at arc BC. Let's look at arc BC. So the angle subtended by an arc, BC in this case, at the center. So these are the ends of the arc and they're subtending an angle of 2A at the center. So this is the angle subtended by the arc at the center. This is going to be twice the angle subtended at the circumference. So same arc BC, the angle subtended from the ends of this arc at the circumference. So the angle made at the center is known as the central angle. The angle made at the circumference is known as the inscribed angle. Okay, so the angle subtended by an arc, so this is the arc at the center. So this angle is twice the angle subtended at the circumference. So this is the circumference. Okay, so the angle at the center is twice the angle at the circumference in simple terms. Okay, so let's see. The angle subtended by an arc is twice the angle subtended at the circumference, same theorem. But here our arc is AB. This is the first case that has already been discussed. So the angle subtended by this arc at the center is this one, which is, as example, 40 degrees. And the angle subtended at the circumference from the ends of the same arc will be 20 degrees. So half of what is at the center. Now let's look at the second case. Okay, so here our arc is AB. So AB is the arc. This is the arc. So which angle is subtended at the center by this arc? So let's see. So this is the angle subtended by the arc at the center. And similarly, this arc, what is the angle that this arc is making at the circumference? So these are the ends of the arc, and this is the angle they're making at the circumference. Okay, so this is an unusual shape, but you need to keep this in mind as well. So this is the center, so this angle will be twice the angle at the circumference. Okay, and this is the third case. This is basically a proof for the first angle property that we did. This one. So this is the arc, right? This is the arc. So the angle subtended at the center. This is the center. So what is the angle at the center? It is 180. It is double the angle subtended at the circumference. So at the circumference, it is going to be half of what is at the center. So since we have 180 at the center, this is going to be 90 degrees. Right? And this also proves our first angle property, that the angle in a semicircle is 90 degrees. Okay, so these are the three possible scenarios for putting this property into action. Okay, so given that ABO, angle ABO is 50 degrees, find BCA. BCA. So they want us to find BCA, this angle. Okay, since we know that, I would suggest that whenever you're attempting a circles question, the first thing that you should do is mark all the radii, and the second is that you should mark all the 90-degree angles. So since this is the center, OB and OA are going to be the radii of the circle, which tells you that triangle OBA is an isosceles triangle. So if this is 50, this is also going to be 50. And to find this angle, we are going to use the sum of the interior angles of a triangle. So 50 plus 50 plus angle at the center is going to be 180 degrees. So angle at center is going to be 180 degrees minus 100 degrees. So the angle at the center is 80 degrees. Okay. Now we're going to use the theorem that we've just discussed. Angle at the center is twice the angle at the circumference. So if this is 80, the angle at the circumference would be half of the angle at the center. Okay, so the angle at the center is 80. So the angle at circumference, which is going to be CA, is 80 divided by 2, which gives you 40 degrees. Okay, so this is 40 degrees. Okay, so let's discuss some questions where we can apply these angle properties. Okay, I'm going to go over them very quickly. You can pause, you can take a screenshot, try and solve for all the unknown angles, and then you can match your answers with mine. Okay, so let's see. Let's assume we have a chord here, right? So angle, this is angle A, and this is angle 27. So I hope you can see that angle A is going to be equal to angle 27 degrees because of the theorem that angles in the same segment are equal, right? So this is the chord, an invisible chord you can draw if you want. So angle A is going to be equal to 27 degrees here, okay? Similarly, you can draw a chord here. So if this is 30 degrees, the angles made from the ends of the same chord, which is this in case, it is going to be equal. So angle B is going to be equal to angle 30 degrees. Why? Because this is the chord, and angles made in the same segment are equal. So this is 30 and this is B. So B is going to be 30 degrees. Let's have a look at question number 2. Okay, so let's have a look at this chord first. Okay, so this is 58. So this is also going to be 58. So C is going to be 58. Why? Because angles made in the same segment are equal. So this is 58, this will be 58. Okay. Now let's have a look at this chord. So angle, this is the angle 30. Angles made from the same chord at the circumference. So angle E is going to be 30. Okay, so this is the chord. Angle made at the circumference. Angle made at the circumference from the ends of the same chord. So this is 30, this will be 30. So angle E is going to be 30 degrees. What is left? Angle D. Okay, again, simple. Look at this chord. Angle made at the circumference from the ends of the same chord are equal. So since this is 41, this will be 41. So angle D is equals to 41 degrees. Okay. Okay, we can draw an invisible chord here if you want. So angle, this is 40 degrees. So angle F is also going to be 40. So this is the chord, this is 40, this will be 40. So F is equals to 40. Okay. Now we know that if this is 40 and this is 85, we can use the sum of interior angles of a triangle to find G. So 180 minus 85 minus 40 gives you 55. So angle G is 55. And if angle G is 55, let's draw an invisible chord here. If G is 55, so then H is also going to be 55. Okay, so this is the chord. This is the angle made at the circumference 55. So it is going to be equal to 55 as well. Okay. So what I'm going to do is that I'm going to write down the answers of all the angles. Here, if you're stuck on any question, just comment and I will get back to you. What we can do is that I can solve the last question, hoping that it is slightly different or trickier than the rest. Okay, so this is the center of the circle. Okay, so this is the chord, this is the angle made at the center of the circle. And we know that since this is the center, this is all these three lines are the radius. So we have an isosceles triangle here. So if this is an isosceles triangle, then this side will also be equal to A. So to find the value of A, what are we going to do? We are going to use the sum of interior angles of a triangle. So 2A, or basically A plus 108 should be equal to 180. So 2A is equals to 180 minus 108. So 2A is equals to 72. A is equals to 72 divided by 2, which gives us 36. So A is equals to 36. Okay, now let's look at angle X. So if we draw an invisible chord here, so angle made at the center, so this is the angle made at the center from this arc, or you can draw a chord, whatever you're comfortable with. Since we've learned the theorem using the arc, so this is the arc. Which angle is being made by the arc at the center, or which is the central angle? So this is the central angle, right? And which angle is the inscribed angle? Angle made by the ends of the same arc at the circumference. So this is the ends, right? And this is C, the angle made at the circumference. Okay. It seems like angles in the same segment because they're of the same length almost, but you have to be careful. This is the angle made at the center and this is the angle made at the circumference. So these are the ends of this arc. This is the angle at the circumference. This is the angle at the center. So this angle will be twice the angle at the circumference. So basically this will be 2x. Is there any way that we can find this angle? Yes, we can. Since angle on a straight line add up to 180. So if we subtract 108 from 180, we get 72. So this is 72, right? So what is x going to be? We are going to divide 72 by 2, which gives you 36. Okay, now another thing. There was a simpler way to solve it. So look at this chord, this invisible chord. Angle made from the ends of the same chord are equal. Since this was 36, this is also going to be 36. Okay. So here's the answer key to all the questions. Solve them, check your answers against this key, and if you are stuck on any question, feel free to drop in a comment and I will get back to you as soon as I can. Moving on to the next angle properties is with respect to a cyclic quadrilateral. But before we move on, we need to understand what a cyclic quadrilateral is. What is a quadrilateral? A quadrilateral is basically a four-sided polygon. A polygon which has four sides and four angles. So it can be a square, a rectangle, an irregular quadrilateral, trapezium, parallelogram, rhombus, kite, anything. It should have four sides and four angles. Okay. Now, if the 4 points of the cyclic quadrilateral, they lie on the circumference of the circle. So all the 4 points touch the circumference of the circle, then it qualifies as a cyclic quadrilateral. So see, all 4 points are on the circumference, right? So this is also a cyclic quadrilateral. 1, 2, 3, 4, all 4 on the circumference. It is a cyclic quadrilateral. However, see, this is not a cyclic quadrilateral. Why? Because 2 points are on the circumference, but these 2 are not on the circumference, right? Similarly, this is not a cyclic quadrilateral. Why? Because the 3 points are on the circumference, but the 4th one is not there. Now, if you have a cyclic quadrilateral, then there are some special properties that become applicable. So the first property is that the interior opposite angles in a cyclic quadrilateral are supplementary. Supplementary means they add up to 180. Okay, so this is one interior angle, and which angle is the opposite interior angle? So the angle opposite to this one is this. So basically angle A and angle C should add up to 180. Okay, and let's have a look at angle B. Which angle is opposite to it? It is angle D. So angle B and angle D should add up to 180 degrees. Okay, so this is the first property of the cyclic quadrilateral that you should keep in mind. The second one is basically the one that you can also derive very easily. The second property states that the exterior angle, the angle outside the cyclic quadrilateral. Okay, so the exterior angle, so it is angle E in this case. The exterior angle is equal to the interior opposite angle. So which angle is opposite to it? This one, the interior opposite angle. So basically angle A is equal to angle E. Now why is that the case? So let's assume A is 70. If A is 70, then C will be 110. Why? Because all of A and C should add up to 180. So 70 plus 110 gives you 180. Now since C is 180, and in case you need to find the value of E, we know that angles on a straight line add up to 180. So if this is 110, this has to be 70 degrees. Okay, so now you can see that angle E is equals to angle A. So these are the two properties that you should keep in mind with respect to cyclic quadrilaterals. So find the size of the angles labeled A and X. Okay, so 1, 2, 3, 4, all 4 points on the circumference. So this is a cyclic quadrilateral. So this angle and this angle should add up to 180, and this angle and this angle should add up to 180. So let's see. What we're saying is that A plus 81 degrees should be equal to 180 degrees. Why? Because the sum of the interior opposite angles of a cyclic quadrilateral are supplementary. So they should add up to 180. Okay, so A is going to be 180 minus 81 degrees. So A is equals to 99 degrees. Okay. Now let's have a look at the other interior angles. So 2x and x should also add up to 180. Let's write that down. So 2x plus x should be equal to 180. So 3x is equals to 180 degrees. X is going to be 180 divided by 3. So x is going to be 60 degrees. Okay, so now to put this property to application, I'm going to randomly solve any two questions. So maybe question 4 and question 8. Okay. And I will then put up the answers for the rest of the questions. You can solve them on your own to check your understanding. And in case of a problem, confusion, or somewhere that you're stuck, you can always comment and I will get back to you. Okay, so A, B, C, D, all 4 points on the cyclic on the circumference. So this A, B, C, D qualifies as a cyclic quadrilateral, which means the opposite interior angles are supplementary. They must add up to 180. Okay, so we need to find angle H. And since this is an isosceles triangle, if this is angle H, this will also be H. Let's write down whatever we know. Okay, is there any way that we can find this angle? Yes, because angles on a straight line add up to 180, right? So 180 minus 106 would give you 74. So this is 74, and since the interior opposite angles of a cyclic quadrilateral are supplementary, so this angle plus this angle should be 180. So 180 minus 74 gives you 106, right? So we could have gotten to this angle directly as well, using the property that the exterior angle is equal to the opposite interior angle. So that would have saved you a couple of minutes. Okay, now since this is 106 and we know that this is an isosceles triangle, we know that 106 plus h should be 180. So 106 plus h is 2h is equals to 180 degrees. So 2h is going to be 180 minus 106, which gives you 74. So h is going to be 37 degrees. Okay. Let's try question number 8. Okay, so again, since this line is equal to this line, this will be angle W. And please note that A, B, C, D, all 4 points are on the circumference. So this qualifies as a cyclic quadrilateral. Okay, so since this is 32, okay, another thing, this is the center, so this and this angle, this length is OB is radius and OA is also radius. Okay, so let's mark these as equal, and since the two lines are equal, two angles will also be equal. Okay, so if we have 32, we can also, looking at triangle OAB, we have two angles, we can find this third one, right? So 32, 180, so it's 32 plus 32 plus this unknown angle, let's call it theta, plus theta should be equal to 180 degrees. So theta is going to be 180 minus 64 degrees. So the value of theta is 116 degrees. Okay, so let's write down the value of this. 116. Okay, now we know that angles on a straight line add up to 180. So to find the value of angle T, we're going to subtract 116 from 180, which gives us 64. So the value of T is 64. Okay, now what are we left with? We know that, please also note that OC is also a radius originating from the center to the circumference of the circle. So let's mark this, which means that triangle OBC is an isosceles triangle. So if this is N, this will also be N. Okay, let's use another color. So basically 64 plus n should also sum up to 180. So 64 plus 2n should be equal to 180. 2n is equals to 180 minus 64, which gives 116. So n is going to be 58 degrees. Okay, 58. So n is equal to 58 degrees. Now we know that since this is a cyclic quadrilateral, the interior opposite angles must add up to 180. So 32 plus w is this angle and 58 plus w is this angle. They should add up to 180. Let's write this down. So 32 plus w plus 58 plus w should be equal to 180. Since we have an equation with only one unknown, we can very easily find the value of that unknown. So 2w is equals to 180 minus 58 minus 32. 2w is equals to 90. W is equals to 45 degrees. So the value of w in this case is 45. Here are all the answers. Please attempt questions, check them against this key, and get back to me in case of a problem. Okay, now let's look at these questions. Again, I'm going to do maybe question number 12 only, and you can do the rest on your own. Okay. So A, B, C, D, all 4 points on the circumference. So A, B, C, D qualifies as a cyclic quadrilateral, which means 95 plus y should add up to 180 degrees. Okay, so 95 plus y should be equal to 180 degrees. Why? Because the opposite interior angles of a cyclic quadrilateral are supplementary, which means they add up to 180. So y is going to be 180 minus 95 degrees. So y is going to be 85 degrees. Okay. Actually not y, only part of y. So this is 85 degrees. Okay. And y is this bigger angle, this entire angle. So we also need to find this little value in order to find the complete value of y. Okay, now since we know that AED is an isosceles triangle, so if this is x, this angle will also be x. Okay. So first, I think we should find the value of x, which we can very easily. If we have a look at triangle AED, so it is 120, x and x. So 120 plus x should be equal to 180 degrees. So 2x is equals to 180 minus 120, which gives 60 degrees. So x is equals to 30 degrees. So the value of x is 30. So this is the first unknown. And to find the value of y, we're going to add 85 and 30 together. So that gives us 115 degrees. So here are the answers for these questions. Please solve them and check them against the key and get back to me in case of a problem. And that wraps up our deep dive into all the theorems on circles. We've gone through each one in detail and applied them to textbook questions to make sure everything's crystal clear. In the next video, we'll take it up a step further. We will apply all these theorems together to real past paper questions and seeing how they appear in exams. So if you found this helpful, please feel free to give it a like, share it with a friend who's also revising, and subscribe so you don't miss the next one. Till then, keep practicing, stay confident, and good luck with your studies. See you in the next one.